Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, matriculants, today we're going to be kickstarting a new topic known as sequences and series. But it's actually not very much a new topic because you've done it in grades 8 to 11. It was just otherwise known as number patterns. In grade 12, we like to be a little bit fancy and call it sequences and series. Let's get started with arithmetic sequences, which were otherwise known as linear patterns in grade 11. We know that arithmetic sequences are characterized by what we call a common difference. This means that if you take term 3 and subtract term 2, you should get the same answer as you would get if you took term 2 and subtracted term 1, or if you took term 4 and subtracted term 3. In other words, all consecutive terms in an arithmetic sequence have the same difference. In an example, if we had the arithmetic sequence 2, 7, and 12, 7 minus 2 is 5, and 12 minus 7 is also 5. Therefore, this has a common difference, and we can confirm it is an arithmetic sequence. Before we talk about the nth term of an arithmetic sequence, I want us to drill down this point just a bit further through this interesting example here. This question says 6, 2x plus 1, and 3x minus 3 are the first three terms of an arithmetic sequence. Calculate the value of x. If you know how to work this out, pause the video, go ahead and try, and then compare with what I have. You see, if we're being told it is an arithmetic sequence, we then know that term 3 minus term 2 should be the same as term 2 minus term 1. In our case, term 3 is 3x minus 3, while term 2 is 2x plus 1. That should be equal to term 2, which is 2x plus 1, minus term 1, which is 6. Solving this equation, we get 3x minus 3 minus 2x minus 1 is equal to 2x minus 5. Now, 3x minus 2x is x, while negative 3 minus 1 is negative 4. So x minus 4 is equal to 2x minus 5. I'm going to make my life easier and move this negative 5 to the other side to become positive 5. Then move this x to the other side to become negative x. So we can see that therefore x is just 1. We were able to solve for x because we were told that this is an arithmetic sequence, and we know that arithmetic sequences consecutive terms have the same difference. In other words, term 3 minus term 2 is equal to term 2 minus term 1. Now let's talk about the general term, otherwise known as the nth term, or otherwise known as the rule of an arithmetic sequence. We know, you should know by now, that that is Tn is equal to a plus n minus 1 times d, where a is the first term and d is the common difference. Let's look at an example. Say we were given the sequence negative 4, negative 1, 2, and then 5, and we were asked to determine the nth term. Well, we know that the common difference d can be seen as, say, term 3 minus term 2, so 2 minus negative 1, that's 2 plus 1, which is 3. So the common difference d is 3. This makes sense because minus 4 plus 3 gives us minus 1. Minus 1 plus 3 gives us 2. 2 plus 3 gives us 5. So we can see that indeed there is a common difference of 3 there. Now, the nth term we said is given by the formula Tn is equal to a plus n minus 1 times d. So in our case, Tn is negative 4 plus n minus 1 times the common difference 3. Therefore, Tn is equal to negative 4 plus 3 into n minus 1, which means Tn is equal to negative 4 plus 3n minus 3, which means Tn is equal to 3n minus 7. This is the nth term. Now, before we answer B and C, I want to clarify something really important here. You must know the difference between a term number, otherwise known as n, and the value of a term, otherwise known as Tn. Like in our little example here, the first term has a value of 2. In other words, when n is 2, when n is 1, Tn is 2. The second term has a value of 7. In other words, when n is 2, Tn is 7. The third term has a value of 12. In other words, when n is 3, Tn is 12. Know the difference between a term number and the value of a term. This will come in very, very handy. In our example, B says to determine the value of the 20th term. Well, we found that Tn is 3n minus 7, right? So term 20 should be 3 times 20 minus 7, meaning term 20 should be 60 minus 7, so it should be 53. C says which term in the sequence has a value of 113. Now remember what we said. A value means 113 is Tn. So Tn is equal to 3n minus 7. 113 is equal to 3n minus 7. So 113 plus 7 is equal to 3n. And therefore 3n is equal to 120. And if we divide both sides by 3, we would get that n is 40. Great. I have one more question on this example, and I wrote it in red because it's interesting. It says which term in the sequence has a value equivalent or equal to 40 T3 plus 6. Some of you might know how to work this out. Pause the video, give it a try, and compare with what we have. Some of you may be confused, but worry not. Let's tackle this piece by piece. The question says which term has a value of 40 T3 plus 6. How about we figure out what this is first? What is 40 T3 plus 6? Well, it has this portion T3. Let's find out what is T3. Remember, Tn is 3n minus 7. And so T3 should be 3 times 3 minus 7, which is 9 minus 7. So therefore T3 is 2. You can see that visually here, that term number 3 has a value of 2. So now we know 40 T3 plus 6 is the same as 40 times 2 plus 6. So 80 plus 6. So 86. We can now sort of rephrase the question. The question is, which term in the sequence has a value of 86? And we know how to answer a question like that. Tn is equal to 3n minus 7. We replace Tn with 86 because we are told this term has a value of 86. And so we get here that 86 plus 7 is equal to 3n. And so 3n is equal to 93. And if you divide both sides by 3, you would get that n is 31. In other words, it is term number 31 that has a value equal to 86. It is term number 31 that has a value equal to 40 T3 plus 6. I hope this makes sense. Moving on, let's talk about quadratic sequences. You looked at these in grade 11, and we said they're characterized by what we call a second difference. But what is a second difference? Well, here's an example of a quadratic sequence: 11, 18, 27, 38, and 51. See, if you took the second term 18 and subtracted 11, you'd get 7. If you took 27 minus 18, you'd get 9. If you took 38 minus 27, you'd get 11, and 51 minus 38 would be 13. See, there is no common difference because the difference between each two consecutive terms is not the same. There is no common difference. But what if we took the differences of these differences? 9 minus 7 is 2, 11 minus 9 is 2, 13 minus 11 is also 2. This is what we call a second difference. Now, the general form of a quadratic sequence is Tn is equal to an squared plus bn plus c. Now, you will have to find the values of a, b, and c. How do we do that? Well, luckily for us, there are some magical mathematical formulas that help us do that. The formulas are as follows. 2a is always equal to the second difference. Then 3a plus b is always equal to the first difference. What does that mean? Well, it just means this number over here, the first first difference. Remember, in quadratic sequences, we have first differences and second differences. So 3a plus b is always equal to the first difference. In this case, that would be 7. The last magic formula says a plus b plus c is always equal to the very first term, this guy. Let's look at this in practice. If we were given the sequence 2, 12, 26, and 44, determine the nth term. Well, first of all, what's the second difference? We have 2, 12, 26, and 44. The difference between 12 and 2 is 10. The difference between 26 and 12 is actually, what is 26 minus 12? 14. And the difference between 44 and 26, that's 18. Now, what is 14 minus 10? That's 4. What about 18 minus 14? That's also 4. So the common difference here is 4. Now, one of our magic formula says 2a is always equal to the second difference. In other words, 2a in our case is equal to 4. We can use this to solve for a. We get that a, divided by 2 is 2. The second magic formula says 3a plus b is always equal to the first difference, which in our case is 10. Since we already know that a is 2, we can go ahead and plug 2 there. 3 times 2 plus b is equal to 10. So 6 plus b is equal to 10, meaning b is 10 minus 6, which is 4. Lastly, the third magic formula says a plus b plus c is always equal to the very first term, which in our case is 2. So 2 plus 4 plus c is equal to 2. So 6 plus c is equal to 2, meaning c is 2 minus 6, which is negative 4. Therefore, since Tn is equal to an squared plus bn plus c always, then Tn in our case is 2n squared, since a is 2, plus 4n, since b is 2, minus 4, since c is negative 4. Now, this question says, which two consecutive terms have a difference of 126? Now, before we talk about it, I just want to explain something here, and that is the line of first differences in a quadratic sequence is in fact an arithmetic sequence. Now, what do I mean by that? Let's have a look at this here, a quadratic sequence, 11, 18, 27, 38, 51. This is quadratic because it has a second difference of 2. But imagine if we looked at 7, 9, and 13 as a sequence itself. What I want you to notice is that that sequence has a common difference of 2. That's why we say that the line of first differences in a quadratic sequence is in fact an arithmetic sequence. If we called this black pattern here Qn, I'd say Qn is a quadratic sequence. Why? It has a second difference of 2. And if we called this middle one here Pn, I'd say Pn is an arithmetic sequence because it has a common difference of 2. Now that said, the question here says, which two consecutive terms in this pattern, this quadratic pattern, which two consecutive terms have a difference of 126? Well, remember that here, the second difference is 2. This is the line of first differences. And the question is, in this pattern, which two consecutive terms, consecutive just means next to each other, have a difference of 126. Now, indirectly, this question is asking you, when does this pattern here have a value of 126? As this pattern goes on and on and on, at some point, it'll have a value of 126. And the question is, which two consecutive terms above it here would have given us this first difference of 126? This is easy to find because, like we said, this is a linear pattern or an arithmetic sequence. So let's find the general term of that arithmetic sequence. Great. 2, 12, 26, 44, 10, 14, 18. Is that right? Yes. Okay, cool. Well, A is 10, D is 4. Tn is equal to A plus n minus 1 times D. So Tn is equal to 10 plus n minus 1 times 4. Tn is therefore equal to 10 plus 4n minus 4. Tn is therefore equal to 4n plus 6. This is the general term for this pattern. And the question is, when does that pattern have a value of 126? And so we plug in place of Tn 126. We get here 126 minus 6 is equal to 4n, meaning 120 is 4n. And if I divide by 4 on both sides, n is equal to 30. In other words, it is the 30th term of this pattern that has a value of 126. But remember, the question was asking about the two terms above the term that gives us a difference of 126. What are these two consecutive terms? Well, when n is 2 in this middle pattern, it is between term 2 and term 3 of the quadratic pattern. When n is 3 in this linear pattern, it is between term 3 and term 4 of this quadratic pattern. So when n is 30 in our linear pattern, then it is between term 30 and term 31 of the quadratic pattern. So therefore, term 30 and term 31 have a difference of 126. Give this a thought, because it is actually quite a common question when you do quadratic sequences. Now, let's talk about the new stuff, and that is geometric sequences. We start talking about geometric sequences in grade 12. Geometric sequences are characterized by what we call a constant ratio. In other words, if you take term 3 and divide it by term 2, you should get the same answer as if you took term 2 and divided it by term 1. Let's look at an example for that. Here we have 3, 6, 12, and 24. If you take 6 and divide it by 3, what's the answer to that? 6 divided by 3. It's 2, right? What about 24 divided by 12? That is also 2. That's what we mean when we say a geometric sequence is characterized by a constant ratio R, which is term 3 over term 2, or term 2 over term 1. Now, the general term, or the nth term of a geometric sequence, is Tn is equal to A times R to the n minus 1. Let's look at an example. Here we have been given that there's a geometric sequence with 3, 6, 12, and 24, and we're asked to determine the general term. Well, R, like we saw, is 6 over 3, which is 2. Now, Tn is always equal to A times R to the n minus 1, meaning Tn, in our case, is 3, since the first term is 3, times 2 to the power of n minus 1. This is the answer. This is the general term. And if it's your first time seeing this, maybe it might be a bit weird, but if you test it out, it actually works. See, term 1 would be 3 times 2 to the power of 1 minus 1, which is 3 times 2 to the power of 0. But remember, any number to the power of 0 is just 1. So term 1 is 3. Term 2 is 3 times 2 to the power of 2 minus 1, which means term 2 is 3 times 2 to the 1, which means term 2 is 6. And as you can see, term 1 is indeed 3 and term 2 is indeed 6. What type of sequence is the following? And this is the last question. 2, 1, a half, and a quarter. Is it a arithmetic sequence? No, because 1 minus 2, that's negative 1. And a half minus 1, that's negative a half. So there is no common difference. It's also not quadratic. But if you take term 3 And this is how you answer a question like, what type of a sequence is the following? If you take term 3 and divide it by term 2, that's a half divided by 1, which is a half. And if you take term 2 and divide it by term 1, that's 1 over 2. Now, can you see that therefore term 3 over term 2 is the same as term 2 over term 1, and therefore this is a geometric sequence? Well, matriculants, I hope this introduction to this topic makes sense, because we're about to delve right deep into complex kinds of questions on this. See you next.